Okay. Oh. Hello everyone. My name is Ajay Ashokan. I'm a full stack developer at Zerodha, and this is actually my first time talking in a conference. I have done workshops before, but this is completely different, and honestly, I'm a bit nervous. So recently, we released a major update to our flagship app called Kite, and we built that in Flutter from scratch. And we took almost 3 months to build a production-ready app. Like 90% of the app was completed in like 3 months, and we are just 2 developers. So I'm actually here to share my experience building it in Flutter. So at Zerodha, we build platforms for trading in stock exchanges like NSE, BSE, MCX, stuff like that. And we actually do it really well. We are actually #1 in India in terms of number of active clients. And our product, the flagship product Kite, has almost 1 million active devices in App Store and Play Store. And people almost place 3 million orders every day, which actually is like 10% of the entire retail volumes across exchanges. And Kite actually updates the stock prices in real time. So whenever there's a stock price change, we have to update in like few milliseconds. Probably that's the biggest challenge in building the app, because you have to update that very quickly, and at the same time you should not drop the user experience. So initially we started with a native Android. Obviously everyone starts with that. Not now. This was like 4 years back, and we took almost 1 year to build our app. And then we didn't have any iOS app at that time. Then we switched to cross-platform. That was my first mission. We chose React Native. We built the whole thing in like 5-6 months, but we could only push that to iOS. In Android, the performance was so bad. Then we chose Flutter. Flutter, we had a great time building it. As I said earlier, we took only 3 months to build the whole thing, like 90% of the app. So why Flutter? That'll be everyone's question. So in my opinion, Flutter is actually many things done right. So we will start with the workflow. So if you look at the Flutter CLI, it's the best cross-platform tooling. Flutter has the best tooling, period. And it has a command called Flutter Doctor, which actually sets up the whole configuration for you. If you have any issues in your configuration, it will show that you have to run these commands. After running that commands, it will be perfectly fine. 99% of the time, there will be no issues. If you are a React Native developer, you know that for every issue, the solution is rm-rf, npm modules, npm install. But we never had to do anything like that in here. And there are IDE extensions for VS Code and IntelliJ, and they are actually really nice when you are building the UI. And probably the most popular feature of Flutter is the hot reload and hot restart. You have this in React Native actually, and it's called hot module replacement, HMR. And in Android Studio, there is live reload. But the problem is that they are not really consistent. But in Flutter, it's consistent and it is predictable. So hot reload actually takes less than 1 second to do the whole change in the UI, and hot restart takes only less than 2 seconds. So it's actually reducing the development cycle a lot. And the upgrading part, if you are a React Native developer, you'll be find really difficult to upgrade your React Native version. Our iOS version is still stuck at 0.49. We are actually scared to update it, because when we try to update, it basically will break at some internal API, and the errors will be so cryptic we won't be able to do anything. But here we started at 0.56 alpha version, and now it is at 1.21. We had a lot of upgrades in between, and none of them broke. All the APIs are backward compatible. And it is very easy to do automated UI testing as well. So you don't have to use any external tools like Selenium, Appium, stuff like that. You can do automated UI testing just how you write normal unit tests. You write in pure code, and it will execute in like a virtual environment. And moving on to architecture, Flutter has a really unique architecture. It's basically just a Dart library. The entire Flutter is actually a Dart library that sort of connects the two worlds, Dart and Skia. Skia is the 2D rendering engine that powers Chrome. So it's like a battle-tested library. And Dart is a general purpose language. It sort of feels like you have the safety of Java and the easiness to use of JavaScript basically. And Dart builds in 2 modes, JIT for debug and AOT for release. And it uses something called a tree shaking compiler, which means the output will not contain the code that you are not using. It's just like ProGuard, but it works much better than that. And the output binary is a pure native Linux binary. It's a .so file, which means it will be really difficult to decompile it. So if you have like a confidential logic in your app, that's really useful. And Flutter allows communication between the Flutter side and the native side. So you can use something called a method channel to call some native APIs from Flutter. And you can use something called event channels to communicate some events from the native side to Flutter. And the animation APIs are actually really easy in Flutter, and they are really consistent. And the thing is, in Flutter, the whole re-rendering thing is actually really cheap. So you can do that as many number of times you want. So you change something in the UI, you call set state, and in the next 16 milliseconds, it will be updated for sure. And I said 16 milliseconds because it's actually connected with the vertical sync of the graphics. And there are gestures, built-in gestures, just like React Native span responder. And there are built-in physics as well. So you can have spring physics, gravity, friction, stuff like that. So you can actually combine all these things, and you can create like really cool 60 FPS interactions. And 120 FPS if you are using iPad Pro with ProMotion. And there is something called Flutter Embedding API. So Flutter is your Flutter app is like a self-contained app, which means it doesn't really need so much things from the platform to run on its own. It draws its own pixel. The entire screen is actually drawn by Flutter itself. So it's really portable. That's where the Flutter Embedding API comes in. So there is a project called Flutter Desktop Embedding, which actually uses this mechanism. With that, you can run your Flutter app in Linux, Mac OS, and Windows. And Flutter already has some sort of support for Chrome OS and Fuchsia. Plus, there's another project called Hummingbird, which is from Flutter team, that actually ports Flutter to browser. One guy actually ported Flutter to Raspberry Pi. So it will be useful in building kiosk UIs. So it's like 8 different platforms from a single code base. That'll be really cool in the future. And another thing which I like most about Flutter is its customizability. So the thing is that if you want to know how a component works in React Native, you command click on it. You basically land on some TypeScript props file. But if you dig deeper, you can see Objective-C and Java. I mean, really, Objective-C. How many of you know Objective-C? None of them. Oh, okay, you guys are superheroes. The thing is that it's very difficult to read that Objective-C. So it's difficult to understand how it works. If you want to modify the behavior, don't even think about it. But here, everything is in Dart. Every single widget that you see in Flutter is actually written in pure Dart. So you can go inside the Flutter library, you can read the code. If you didn't like it, you can modify it. Any widget, you can modify how it is. Change the colors or change the sizes, anything, you can do anything. So I think the Dart code inside the Flutter is actually really readable, and it is heavily commented, so you have everything you need in there. I think this will actually trigger a lot of community contributions because everyone can read Dart. They are actually making the app in Dart, so they can read it and they can actually contribute more. I'm guessing that will trigger more community contributions. We have gone really crazy on this. We have built everything our designer has asked for. We have done even more. We became efficient to a point. We are actually faster than our developer. We started calling him bottleneck. So here are some cool animations we did. So on the left, we cannot do like a lot of animations because people want to do stuff really fast in this. This is a trading app. So if you lose a few milliseconds, they lose money. So we cannot do much. So on the left side, you can see sort of a morphing between the summary. We do a y-axis translation, and at the top of this top edge of this top layer, you can see a shadow. We animate that, and on above the top layer, you can see an overlay. We animate the opacity of that, and all of things are controlled by a single animation controller. And here are some interactions we did. So on the left side, you can see a sortable list. There is a sortable list in Flutter built in, but the thing is that you have to press and hold on it to start that gesture. So we moved it to the left handle. So you don't have to literally wait 300 milliseconds to start the interaction. So on the right side, you can see a bottom sheet. Again, there is a bottom sheet built into Flutter, but the problem is that it has fixed height. So you cannot change that. So I built one like this. It can contain any widget of any height. So it will scroll accordingly. And if you look really closely, the scrolling is actually a little bit different compared to the built-in Android scroll, because we customized the physics of that scroll. So we sort of added a little bit of extra friction and fine-tuned the timing a little bit. So we have this smooth scroll, and it won't shoot to the end while the user just moves a little bit. So user can actually see what are the content inside it while he's scrolling. And there is something called custom painter. So this actually allows you to draw lines, curves, shapes, literally anything on the foreground or in the background of any widget in Flutter. So this actually adds a lot of, you can basically draw anything on this. So on the left side, I don't know if it's clear, you can see the price field and these tags like SL, SLM, they have some sort of fence on top of it. It basically means they are disabled, but we were able to do that with the custom painter and with some maths. You guys remember y equal mx plus c? It's a line equation. And the right side, you can see a trend line with some gradient in it. So that is drawn as a background, and in the foreground you can see a value and the time, the date at that time. So if you scroll horizontally on top of it, this will pop up as a foreground drawing. You can also do theming. It's not just black and white, by the way. We just have dark and light themes, but you can have any number of themes in your app, and you can easily switch between them. So you can have one single place where you define all your colors, typography, and everything, and you can have multiple instances of that, and you can just switch them between just by changing the variable. So, and you will get this nifty transition between them. This is not done by us. This is done by Flutter while you switch your theme. And the layouting is also really flexible in Flutter. It's actually based on Flexbox, but there are tons of widgets on top of it to make this whole widget UI building process very easy. For example, the row widget is basically setting flex direction row, and center is basically setting align item center, justify content center, and expanded is basically flex 1. And if you think that's not enough, you can use custom multi-cell layout, which can actually position your widget in like pixel perfect location. You can set 0, 0, you can set it at the end, anywhere you want. And if you think even that is not enough, you can extend your classes with render box or render sliver. So in Flutter, a sliver means anything that scrolls, and box is anything that doesn't scroll. And another interesting thing is that this on-demand rendering is actually built into slivers. So this is something you have in recycler view in Android. I think Flipkart built one recycler view sort of thing for React Native as well, right? So the on-demand rendering means it won't render or do the processing required for the elements that's not visible in the viewport. So in Flutter, this is actually built into the sliver system, which means anything that scrolls, scroll view, list view, including tabs, everything will not render the stuff unless it is in the view. So if you have a tab bar that has multiple sheets on it, it won't render the second sheet until you start moving the page. So this actually reduces the memory consumption a lot. And Flutter allows the communication between two widgets in the tree. So you can communicate some data from a parent widget to the child widget through something called an inherited widget. This is like how the React's context API works. And you have something called notification to do the reverse communication. So you can communicate some data from the child widget to a parent widget. So the first one is actually really useful for the theming. So you define your theme, the apps theme, in the root component, apps component, but you will get that value in the like a leaf component, the child component. Maybe it's just a text box. So you can get the color for the text from the root component through the inherited widget mechanism. And notification, for example, suppose you have a scroll view and you have an app bar. You have to hide the app bar when you scroll up. So in that situation, you can use this notification so that you can send the notification that I have scrolled this much from the scroll view to the app bar, so that app bar can move a little bit. You often find that in the first thing will be in many cross-platforms solutions, but the notification part, the reverse communication, is not really present in anywhere. So yeah, we decided to use Flutter, and it was at alpha 0.56. It's a bold move, but it actually paid off. So I was in charge of architecting the app. Since it was in alpha, it means there is not much help from community. So we had to figure out stuff by ourselves. And Kite is actually a really huge app. We have like 50 plus screens and 240 dart files, and only like 4 or 5 of those are generated. So we went on to build a custom HTTP framework, custom state management, and a code generation mechanism. So moving on to the HTTP framework. So the thing is that there are many HTTP libraries for Flutter, but none of them had all the things we needed, like request timeout, caching using e-tags, file uploads. None of them had all the features we needed. So we built one, and look at that constructor. None of them had a good looking constructor like that as well. So look at that constructor. You can just understand what is the API, the entire API request, just by looking at it. And if you look at the last line, you can see a nifty feature. It's a JSON response parsing mechanism. This is actually built into the HTTP framework, which means if the API request is even successful, but the parsing fails, then the framework will report it as failure, so saying unexpected response. And we built a custom state management solution. Again, there are so many state management solutions out there. Scope model, block, there are way too many. So we built one. And because none of them can handle our requirements, all the requirements we needed. So on the left side, you can see something called a mutation. So this is actually based on Redux. So in Redux, you have something called an action and a reducer, right? But here we combined both of them into one unit called a mutation. This is where all the logic of the app lies. So we have like a clear separation between the UI logic and the state. So on the left side, you can see 3 mutations. One is fetch once. This is where the API call starts, and based on its result, either of these will call. So fetch once success or fetch once fail. And you can see a screen declaration here. This listens to all the mutations that I wrote there. So this means whenever a mutation happens there, that sort of sends a callback to screen saying that this mutation has done. You have to reload the re-render the whole screen. And our store is basically a flat model, flat class, nothing fancy in there. And we sort of serialize everything into JSON and store it in the shared preference. We don't use databases because for our use case, it's not really necessary. And we actually need fast access to data, and we do some processing on it. So keeping it in the memory is the best choice for us. So you can see there is a tag, JSON funds, which means only this will get serialized. We won't serialize the entire store, we just serialize only the things that are tagged. And you can see that there is no connection between these, like there is no import or anything. It's because the glue code between these 3 things are actually generated. Actually, the code is actually generated. So as I told earlier, there is this price change thing. So whenever the stock price changes, we have to update it into the app immediately. So for that mutation mechanism is not really a great idea, because if you are connecting this to mutation, then it will render the whole screen, which we don't want, because that will happen like 2 or 3 times a second. And if you are re-rendering the whole screen 3 times a second, that's probably going to be a huge issue. So we sort of switched to a different mechanism called a dot stream. Stream is basically like a channel of data. So whenever there is a price change for a stock, we push that to its own stream. And there is something called a stream builder in Flutter, which actually rebuilds the widget inside it when there is an update. So we sort of created this widget called update on tick, which is a wrapper on top of stream builder. So this means the thing that is inside it, which is a text widget with the last price of the stock, only this will get updated when there is a price change. So the whole mechanism got very lightweight. So instead of rendering the whole screen, we are just rendering only a text field. So this became really lightweight. And the code generation. I've been talking about this for a very long time. So this is actually the biggest piece in the Kite's architecture. Because instead of writing boilerplate code or the things that just get repeated, we just write code to generate that code. So that's what I meant by code generation. So all the boilerplate, all the repeating thing, everything gets generated. So we use the metadata we write to generate this thing. So people actually use this for generating JSON serializers in Flutter. But we actually took it to a next level. Almost everywhere where we are lazy to write code. I admit it's a bad idea. It's not. It's an abuse basically, but it really worked for us. So this is how we generate the model. So on the left side, you can see just a class with a couple of fields in it, and you can see some of them are actually tagged with JSON, a field name, and that's our input. And this is the generated code. So here you can see that it's just copying stuff between the class variable and the data in the map in the JSON. And for toMap, we does this reverse part. Just copy the stuff in the class to a map. This is how we do the serialization part. We use the same mechanism for serializing our store. So persisting our store is actually done by the same mechanism. This actually supports a nested model. So you can have a person class, you can have an address class. So this can serialize even that. And you can have enumerations, you can have null values, you can have default values, you can have lists, maps, and stuff like that. And this is how we generate the mutation. So on the left side, you can see the mutations I showed you earlier, the fetch one, success, and fail. And this is the code we generate for that. So here you can see the fetch funds actually connects the original request and these two functions, fetch one success and fetch one fail. That's the job of the first wrapper. For next two mutations, we just call the original function and we call notify. So this notify is the function that sends the callback to the screen saying that you have to re-render the whole screen. And even this is also doing this. So when we call this, it will get notified. So we'll show a spinner. Then after these two or any of these two, we'll stop the spinner. If it is success, we will update the content. If it is failure, it will show a snack bar on the screen. So that's how we structure all the API calls in our app. And this is how we generate the screen. So we define screen like this with a set of list of mutations that the screen is listening to. And we generate this. Again, not a great idea. Don't do this if you're using Flutter. There are much better ways Flutter team actually recommends. But since we are actually only 2 developers, we went for this idea. So here you can see we are actually collecting the handle of the screen and we are calling the subscribe function. So this subscribe to all the items in the listen to array so that it can get the callbacks from the mutations. And we generate enumerations. So in Dart you have enumerations, but they are just integers, just 0, 1 like that. But in our case we needed, we have way too many situations where we needed like a string enumeration. So here, this is basically just a key value pairs, like invalid, then small letter, invalid, valid, valid, like that. But this actually reduces the situations in the app where you have to hard code the strings. So this is our input, the one on the top is the input, and this is the generated code for that. Here you can see we are just initializing a object of the state, that class with the value inside it, and that's it. You can also iterate between the keys, values, and the actual items. So this is actually useful in the UI. As I said, you don't have to hard code the strings in it. We use that for API URLs as well. So we are like routes.api root plus routes.funds, like that. And this is a logging mechanism we built. It's called logdaemon. It's actually a byproduct of Kite. So we actually missed the React Native debugger, which actually does the same thing. So I actually built it in Electron.js, and this screen you're actually seeing is actually modified Chrome DevTools. You can only see 3 tabs. And I wrote a client library in Dart for communicating between Flutter and the logd. So you can see, you can stream all the things in the app. And you can log from external devices as well. It's not just for simulators. So you can log from external devices, but they have to be in the same network. So it basically adds all the console.log, console.warn, console.error, all those functions to Flutter. So you don't have to use the print statement in Flutter. So here we actually log the mutations. You can see all the mutations that's running. You can also see the previous state and the new state after running the mutation. So you can actually see what are the changes that's done by that mutation. And you can also use the filtering mechanism of this Chrome DevTools. You can filter the log as well. You can also watch the API calls. This is basically all the Chrome DevTools features. We just like sort of proxy it. So you can watch all the API calls. You can see the request and response. You can see the API timing. So if you have an API that takes a lot of time to complete, you can actually monitor that. You can also configure network conditions like offline, online, 2G, 3G. You can emulate that. And logd actually exposes a persistent storage API. So this is actually based on the local storage API of the browser. The thing is, if you are in debug mode, and if you use persistent storage API of logd, then you can actually see what is app storing in the shared preference. So, which is actually really nice. And in the release mode, you can use the original shared preference. So if you want to emulate like a fresh install of your app, you can just click on that clear, and it will clear everything. And next time you restart, you have a fresh installation. You don't have to go to the app settings, clear storage, clear cache. You don't need to do that. So yeah, we built the whole thing in Flutter. Currently it is in beta. You are actually supposed to listen yesterday, but we couldn't because exchanges didn't give us the permission to do that. So we had to sort of give a demo of our app to them. So yeah, we had a great time building Kite on it. And so your question will be whether I should use Flutter or not. So in my opinion, if you have a really small team, you have a really customized UI, and if you don't have much time to build the app, or all of these things, which was our condition, then actually Flutter is a really great choice. Also, if you are using a JS framework and you need a much better performance, then you can use Flutter actually, because it's completely native. It's not JS, it's not getting interpreted, it's actually compiled. There are some quirks as well. The most popular one is there is no proper WebView support. There is actually a WebView package by Flutter team, but it's in developer preview. So once it comes out, I think this issue will not be there. And in our case, we are actually creating an active Android activity on Android and a custom UI, a view controller in iOS. Because in our case, we needed a full screen web view with all the features in it. So we went for the native option. And there is no proper multi-API support. It's not a big deal. Because the thing is that you cannot have one single APK with all the architectures in it. The ARM, ARM64, x64, x86, all those things in a single APK or in a single app bundle. It's not there right now, but they are actually working on it. But you can have split APKs, by the way. So you can have different APKs for different architectures. And there is no reflection. Dart has reflection, but Flutter removed it because of the tree shaking compiler. So you have to use code generation. Don't do code generation like we did. Use it only for model generation because that's the best thing to do. So in a nutshell, Flutter is a great option for many use case. I will recommend you to consider it for your next project or rewrite. And it may not be like you won't like it on the first sight because there are so many things that's different in Flutter. But as you do more Flutter, you will feel that, oh yeah, this makes sense. Oh yeah, that makes sense as well. So make sure you give a second chance. So that's about it. Thanks for listening. Any questions? Do we have time for?
Can you expand on the point where you said best suited for small teams?
We are just two people in our company.
I understand.
So, yeah.
But why did you say that? Why is it not like, why is it hard to scale when you have a lot of developers in the team?
No, I didn't mean that.
Okay.
I'm saying if there is a constraint of your team, then Flutter will actually give you more productivity.
And it's also good for larger teams?
Oh, of course, yes.
Okay.
Because each and every, you can actually work on different screens by one single person, because that whole screen thing or that widget thing is actually completely modular. You can write UI testing just for one particular widget.
Okay.
So it's completely modular. You can work on one piece actually. So it's actually, yeah.
Okay, so the other question is, you talked about UI tests, right? So which are like high-level tests that people write, right?
Yes.
Let's say we have developers, but we don't want them to be writing these high-level tests, right?
Yeah.
Like sanity or end-to-end tests.
Okay.
Can some other team, like a QA team, write a sanity suite for all your applications? Is that possible without having access to the source code?
You don't need access to source code actually.
Okay.
But you will need to know Dart.
Okay.
Because that's how you write tests in this. And you can use the external tools if you really want, like the Selenium, Appium, and all those things. You can use the.
You can still use it on Dart.
Yeah, sure, yeah. And there's something called a Flutter driver instead of the Android driver and iOS driver. Yeah.
Okay. And the last question is, can you talk about event and event channels and that is the bridge between the native part and the Android and the Flutter application itself?
Yes. It's
so
sort of
what kind of limitations do you have? Like how does data get serialized when it is passed through the bridge, and how do you deal with debugging or finding faults between native and Flutter?
So they have something called a messaging codec. That's how they serialize it. It's not JSON. So this was the issue with React Native, because they had one single bridge, single threaded two-way communication that had JSON passing through that. So that was really slow. But here they actually have their own. I'm actually not sure how it actually works, but that's not JSON. It's something called codec. So if you have like a custom data, you have to write your own codec. Like if you have a really huge file and it's a custom codec and that doesn't work with the built-in one, then you have to write your own.
Say for example, if you're doing analytics, right? Then you have an SDK.
Yeah.
If your analytics provider does not give you a Flutter SDK, how do you deal with the situation?
It's fine. It'll be like a couple of functions, right? Like a set screen, send this event.
So you write a custom bridge for both Android and iOS?
Yeah, exactly. Yeah. It's really easy actually.
Okay.
And you can simultaneously develop that and the Flutter app in two different IDEs. This is an issue with React Native because there is no proper ID support while you are writing native modules. Okay. You have to sort of guess. But here in the Flutter project, if you right click on Android folder, you can have an option that open in Android Studio. That has all the IntelliSense with the Flutter code in it. I mean, the connection with the Flutter code.
Okay. Thank you. That's all I have.
Hi, I'm Shiva from Zoho. So we have actually built a spreadsheet application, and we have it on store. Okay, it's a full-fledged native Android application, and it's there for iOS as well.
Okay.
So we are actually investigating whether it is possible to build UI components with Flutter and then use it in both iOS and Android native apps.
Yeah, you can do that. There is something called Flutter View, where you can embed that Flutter widget inside your native application. Okay. And you can do the reverse as well. Okay. Which is what we done for WebView in our case.
Okay. So could you tell me how easy it is to actually call the native?
I think I cannot comment on it because I have not tried it. Because ours is purely Flutter app. Yeah. But so many people are actually using it. Like Alibaba did that for their app. So their app is actually native, and they moved their entire piece of the app using Flutter for like a couple of screens using this Flutter View thing.
Okay. Okay. Yeah. Also, I would like to know if there is any how is the app size actually with this?
Yeah, so the simplest app, the Hello World, will be like 5 MB, and our app is like 10 MB, and that's just because